this video, we'll be covering how to find the extrema and critical points of a function,
as well as the inflection points, concavity, and intervals of increasing and decreasing of a function, both by looking at the graph of its derivative and by looking at the function.
We will be able to find all these components by using 3 tests: the first derivative test, the second derivative test, and the inflection point test. First, we'll start off with the first derivative test. So the first step is taking the derivative, or f prime, of the given function. Set the function equal to 0 and find the x values that make f prime equal 0. Anywhere that f prime is greater than 0 means that the original function is increasing at the point. Wherever f prime is less than 0, the original function is decreasing. To find the minimum or maximum of the original function, use the x values you found in the first step. If the derivative changes from negative to positive at 0, then that is the x value of a minimum of the function. Likewise, if the derivative goes from positive to negative, you know this is a maximum.
Next is the inflection point test. The inflection point test tells you the concavity of the original function as well as the inflection points. You have to find the second derivative of the given function and set it equal to 0 to find all the x values. If the value is greater than 0, the function is concave up, meaning it has a dip and likely a local minimum. If the f double prime value is less than 0, the function is concave down and the graph looks like a hump, and probably has a local maximum. If the f double prime value is equal to 0 or is undefined, then you can test it using a sign chart.
Last is the second derivative test. The second derivative test can be used, for example, when you have critical points. To find those critical points, set the derivative of the function to 0 and find the x values. Then find the second derivative and plug in those x values. If what you get is greater than 0, that means the critical point is a maximum. If you get a negative number, then the critical point is a minimum. This is the graph of the derivative of a function y. We can find out a lot about the function just by looking at the graph of its derivative. We know from the first derivative test that when y prime goes from negative to positive and crossing the x-axis, that point where it equals 0 is a minimum of the function. So here, the x values would be negative 0.414 and 2.414. For maximums, we know that when y prime goes from positive to negative, that those points are maximums of y. Here, those points would be x equals 1. The intervals can be found using the first derivative test as well. When y prime is negative, the function is decreasing as seen here. So this is the decreasing interval. It's just the opposite for increasing. So here is the interval for when the function is increasing. The inflection points can also be found. The minimum and the maximum of the derivative are also the zeros of the second derivative, so we know those points are inflection points.
Here we are given a function. There are several things that we can do to find out more about the function and what its graph looks like.
To find the inflection points, you have to find the second derivative and set it equal to 0 to find the x values. When you plug in the x value into the original function, you will get a point that tells you where the graph changes in concavity, or the inflection point. Because the value is 0, you can use a sign chart of y double prime to see how it changes in concavity. By plugging in a value that is less than 0, you'll get that y double prime is equal to a negative number, and by plugging in a value greater than 0, you'll get that it's a positive number. So this will tell you that because this is negative and this is positive, it's changing from concave down to concave up at the point 0, negative 2.
Now we're going to find the critical points. To find the critical points, you first have to find the derivative of the original equation. In this case, it's 3x squared minus 3. We then set this derivative equal to 0 and solve for x. We then take this x value and plug it into the original equation to find our critical points.
To find the minimum and maximum of the function using the second derivative test, you take the x values from the critical points found over here and plug it into the second derivative that we found up here. So when you plug in 1 to the second derivative, you get that 6 times 1 equals 6, which is a positive number. And according to the second derivative test, if y double prime is greater than 0, then it means it's a minimum. When you plug in negative 1, we get that 6 times negative 1 is negative 6. And that's a negative number, meaning when y double prime is less than 0, it is a maximum.
We're going to find the minimum and maximum of the function using the first derivative test. We're going to do this by utilizing the sign chart of the derivative. Here we're going to plug in a number less than and greater than negative 1 and 1, which are our critical points, into the derivative of the original equation. Here we find that numbers less than result in a positive number and numbers greater than will result in a negative number. Therefore, this means that negative 1, 0 is a maximum. For 1, we find that it's a minimum.